Mercedes-Benz, one of the leading luxury car manufacturers, is still feeling the heat in the electric vehicle market. The company has reported a challenging third quarter as heavy price cuts and supply chain issues put pressure on their earnings.
Mercedes-Benz says the market for electric vehicles is getting brutal, and it warns that could bite into profit margins over the coming months.
When it comes to the automotive world, the possibilities are endless. In a recent sudden announcement, Mercedes informed the world about a groundbreaking innovation that could completely change the auto industry's future. This isn't just a new engine, it's a direct challenge to the dominance of electric vehicles.
Mercedes said fierce price competition and supply chain issues were making the EV market a tough battle.
Promising jaw-dropping range, unmatched durability, and sustainability we've never seen, this innovation could upend the entire EV market. Could this be the moment combustion technology makes an unexpected comeback? Or is it just the beginning of a new era? Join us as we reveal how Mercedes plans to change the game forever. Mercedes at it again. Mercedes has shocked the automotive world with a revolutionary engine that could change everything we know about cars. They've recently revealed their game-changing Axial flux motors. This marks a major leap in electric vehicle technology. These revolutionary engines, which were produced in-house starting this year, are set to deliver higher performance and greater efficiency for their upcoming electric and hybrid vehicles. This innovation is expected to transform the way Mercedes produces its electric cars.
If electric vehicles are the future, how will we get there using technology from the past?
The motors, which will be used in performance-oriented models like AMG vehicles, are more powerful and efficient. Mercedes plans to build them at its Berlin plant, ensuring tight control over the entire electric powertrain system, which includes the electric motor, battery, and power electronics. This integration aims to make their electric vehicles more reliable and cost-effective, advancing Mercedes' electric strategy as they strive for half of their cars to be purely electric or hybrid by next year. The switch to in-house production of these Axial motors shows Mercedes' push towards vertical integration, reducing its reliance on external suppliers and positioning itself as a leader in the rapidly evolving EV market. These advanced motors will enable more capable hybrids and efficient EVs, paving the way for future developments in electric mobility. Now, you may be wondering what makes this engine so unique. It's not just about power, it's about doing more with less. Early reports suggest this engine uses innovative materials and advanced engineering to deliver unmatched performance while being lighter and more efficient. Think of an engine that offers better mileage, lower emissions, and a longer lifespan, all while keeping costs down. Mercedes has blended traditional engineering brilliance with futuristic thinking, and the results are stunning. But it's not just the specs that make this reveal so exciting, it's the timing. With electric vehicles dominating headlines, Mercedes has taken a bold step in another direction.
The company says some rivals are selling electric cars for less than traditionally powered models, even though they cost more to make.
The company has hinted that this engine could outperform even the best EVs in range and reliability. While EVs rely heavily on charging infrastructure, this new engine could offer convenience and independence, giving drivers freedom without worrying about running out of battery power. This move also reflects Mercedes' vision for the future. The company has always been known for doing the impossible in automotive, and this engine shows they aren't ready to let electric vehicles take over without a fight. So why is it being called a game changer? Because it challenges everything we assume about the future of cars. Mercedes isn't just improving what already exists, they're redefining it. This new engine could force other automakers to rethink their strategies and develop faster, cleaner, and more adaptable technologies. For consumers, this means big things. For years, people have always looked for a car that's powerful, efficient, affordable, and reliable. This engine could lower drivers' costs while delivering a better experience behind the wheel. Mercedes is setting a new standard, and it's one that other brands might struggle to keep up with. Interestingly, the most mind-blowing thing about this innovation is its advanced technology, which promises to change the way we think about power, efficiency, and sustainability in cars. Unlike traditional combustion engines, or even the standard electric motors we're familiar with today, this new system is designed to outperform conventional engines and electric vehicles. To make it more intriguing, let's break down what makes this engine so powerful and why it's already causing a buzz in the automotive industry. The power behind the innovation. Remember that earlier in this video, we mentioned the game-changing axial flux motors. Yes, we made no mistakes. Mercedes' use of axial flux motors is at the core of this groundbreaking technology. These motors differ from the traditional radial flux motors typically used in most vehicles, including electric ones. Axial flux motors are compact, more efficient, and lighter, giving them an edge in performance and reliability. Mercedes has perfected the design of these motors, allowing them to generate more power while using less energy, which is a significant advantage for both electric and hybrid cars. So why does the shape of the motor matter? Think of a fan. The traditional radial fan spins in a circular direction, much like the radial motors, but an axial fan, aligned with the airflow direction, works more efficiently because the airflow is more direct and without unnecessary resistance. Similarly, axial flux motors use a more direct energy conversion method, making them lighter and better at generating high power with minimal loss.
The axial flux motor is integrated here with the reducer, so the whole system is much smaller than traditional motor and it can save more space for the vehicle layout.
With a more compact engine that produces high energy, vehicles using this technology can remain light, fast, and agile without compromising performance. Undoubtedly, efficiency is one of the key advantages of this new engine. Whether combustion or electric, traditional engines suffer from energy losses due to heat and friction, but the axial flux motors are designed to be significantly more efficient, directly converting energy from the power source into motion. Mercedes' new engine design also ensures the vehicle can run longer on a single charge or in a fuel tank. This means fewer stops for recharging or refueling, which is one of the biggest challenges facing electric vehicles. With a more efficient engine, drivers will experience fewer range anxiety moments, and cars will become more practical for long-distance travel. This is a huge step in making electric and hybrid cars as convenient as their gas-powered counterparts. But that's not all. Mercedes has also focused on battery optimization, boosting the engine's efficiency. By pairing these advanced motors with high-performance batteries, the system works seamlessly to provide excellent range without compromising speed or power. This efficiency isn't just about getting more miles out of a battery. It's also about lowering overall energy consumption and making the car more environmentally friendly. But you'll be mistaken if you think you've seen it all, because another standout feature of Mercedes' new engine is its durability. You'd agree that traditional motors can wear out over time due to friction and the heat generated, but the axial flux motors are designed with fewer moving parts and better heat management, making them last longer and perform better over time. Plus, this new engine also boasts reliability. Mercedes has tested it under extreme conditions and has shown it maintains its performance under high and low temperatures, which can often impact a vehicle's ability to perform efficiently. In comparison, many electric cars today suffer from diminished range and power in extreme weather conditions. With Mercedes' new engine, drivers can expect consistent performance no matter the environment. So, by improving both the motor and the supporting systems, Mercedes is creating an engine that doesn't just deliver power. It keeps performing like new for longer. This is important not only for car owners, but also for the environment. As the longer an engine lasts, the fewer resources are required for replacements and repairs, leading to less waste. But do you think with all these features, this new engine has the potential to outperform electric vehicles? Now listen so you don't miss this part. One of the most daring aspects of Mercedes' new engine is how it challenges electric vehicles. Yes, you heard us right. While electric cars have been hailed as the future, they come with challenges, including charging infrastructure, battery degradation, and long charging times. Mercedes' new engine, however, could overcome many of these issues, potentially outpacing EVs in both performance and convenience. For one, the engine could deliver a much higher power-to-weight ratio than traditional EV motors, giving the vehicle more power without adding extra weight. This means cars could be faster, handle better, and accelerate faster. Plus, because the engine is more efficient, it doesn't require the bulky battery packs common in electric vehicles today.
The pioneering e-drive technology is only revealed when you delve deeper. Developed specifically for the EQC, the first Mercedes-Benz of the product and technology brand EQ. The EQC.
This makes it easier to design lighter, faster, and more efficient cars. But the real advantage comes when comparing performance across longer distances. Remember, we mentioned how electric cars rely on charging stations, which can be scarce in some areas. What if we tell you that Mercedes' engine could offer a more practical solution for everyday use? So, drivers no longer need to worry about finding a charging station or waiting hours to recharge their batteries. Instead, the engine's efficiency and durability would make it more reliable for long road trips, a big issue with many of today's EVs. Undoubtedly, Mercedes' decision to develop and use this new engine shows they aren't content with keeping up with trends. They want to set new standards in the industry. This innovative technology isn't just about creating another car, but redefining what a car can do. By investing in this advanced engine, Mercedes is positioning itself as a sustainable, high-performance transportation leader. It makes sense for the environment by improving fuel efficiency and reducing carbon emissions, but it also promises to improve the driving experience, making it more enjoyable, practical, and affordable. In the end, the technology behind Mercedes' new engine has the potential to reshape the future of transportation. Combining the best internal combustion, hybrid, and electric technologies, this engine could create a whole new category of vehicles that are cleaner, more efficient, and more affordable. This engine represents the next generation of driving, where performance and sustainability go hand in hand. It's not just about getting from point A to point B. It's about revolutionizing how we think about cars and their role in our lives and the environment. With Mercedes leading the charge, the future of driving could look very different from what we see today. You would agree that Mercedes' new Axial flux engine is a game changer, but could it be the end of the EV dominance we've seen grow over the past decade? Let's explore the potential implications of this innovative technology and whether it could slow down the electric vehicle revolution or inspire even greater advancements. The challenge to EVs. The EV revolution has been unstoppable for years, fueled by global efforts to reduce carbon emissions and the increasing demand for greener, more sustainable vehicles. The electric motor's quiet, powerful performance has made it the go-to choice for automakers and consumers looking for a cleaner alternative to gasoline engines. Yet while EVs are hailed for their environmental benefits, they still come with challenges like high manufacturing costs, charging infrastructure, and the ever-present issue of battery range and charging time. Mercedes' new Axial flux motor may turn these challenges upside down. This engine is compact, more efficient, and has a higher power-to-weight ratio than traditional motors, making it an appealing alternative for electric and hybrid vehicles. It's expected to offer more performance without needing massive, heavy batteries. This basically means it could make cars lighter, more powerful, and much cheaper to produce while maintaining the same range and efficiency electric vehicles promise. This means the new engine could offer a cleaner solution, even for non-electric cars. But could it slow down the EV revolution? The simple answer is, it could, but not in the way you might think. The Axial flux engine doesn't necessarily compete directly with EVs, but rather introduces a more versatile technology that could challenge current electric models in some ways. The efficiency of this engine could make hybrid cars more attractive, offering a balanced solution between electric power and traditional combustion engines. For consumers who aren't ready to fully commit to an EV, a hybrid powered by this new engine is a better option, slowing the overall growth of the all-electric vehicle market. But while hybrid models may see a resurgence, it's important to remember that this technology could inspire more advancements in electric mobility. The new engine's higher efficiency and lower cost of production could lead to more affordable electric vehicles with better range and performance. Manufacturers may adopt this engine design to improve existing electric models, which would continue to drive the evolution of the EV market. So instead of ending EV dominance, Mercedes' engine could spark more innovation. It forces automakers to rethink the future of cars and how they combine electric and traditional technologies. We may see the best of both worlds: more powerful hybrids, highly efficient electric vehicles, and better infrastructure. The advances made with this engine might lead to breakthroughs in electric batteries. By making the motor more efficient and lighter, there could be an increased focus on improving the batteries that power EVs, leading to better performance and faster charging times. Thus, this innovation could fuel further EV advancements rather than replacing EVs, propelling us closer to the cleaner, greener future we've been promised. As we continue to see new advancements, whether in electric motors or battery technology, the future of the automotive industry looks incredibly exciting. The question isn't whether electric vehicles will dominate, but how innovation will shape and evolve the next generation of sustainable cars. Ehang has developed several innovative aircraft, with the first being the Ghost. This is a quadcopter built in the standard quadrature design, but with a unique feature. Its rotors are mounted below the arms rather than on top.
And I have to say I'm pleasantly surprised by the weight. It feels substantial in my hands. But the airframe and the undercarriage are made of plastic,
as seen in most other multi-rotors. The Ghost, officially named the Ghost Intelligent Aerial Robot, is primarily used for aerial photography and is controlled via smartphone.
The drone, instead of using the transmitter, you use the phone based on this application. So tilting left to right, up, down, forward, backwards, it's all commanded with the phone to the drone.
Its specifications include a wingspan of 0.35 meters, 1 foot 2 inches, a gross weight of 0.68 kilograms, 1 pound, and 4 propellers. In terms of performance, it reaches a maximum speed of 60 kilometers per hour, has an endurance of 25 minutes, a service ceiling of 914 meters, and a climb rate of 2.5 meters per second. Another aircraft Ehang developed is a hexacopter that has yet to be named. This UAV, made from carbon fiber composite material, was first shown to the public in August 2014 at TechCrunch Beijing. Unlike most multi-rotors with straight arms, this hexacopter features curved arms and has a pair of skids as landing gear. Controlled by a laptop, the hexacopter can carry a capacity of 10 kilograms with 6 propellers. Its performance includes a range of 5 kilometers and an endurance of between 30 to 40 minutes. Perhaps Ehang's most impressive creation is the Ehang 184, an autonomous passenger drone.
To this drone you see behind me, the Ehang 184.
Capable of reaching speeds over 100 kilometers per hour, it began carrying passengers in 2015, with over 40 trips completed by February 2018. In the 3 years leading up to that, more than 1,000 test flights were conducted, including challenging flights in stormy conditions, low visibility, and nighttime operations. The Ehang 184 has 8 propellers mounted on 4 arms and can carry 1 passenger. By July 2018, 30 to 40 single-pilot models had been built. The drone's specifications include a length of 3.86 meters, a wingspan of 5.5 meters, and a height of 1.44 meters. In terms of performance, it has a cruise speed of 130 kilometers per hour, a range of 16 kilometers, and a service ceiling of 500 meters. Ehang 216 is a 2-seater aircraft equipped with 16 propellers arranged in a coaxial double-blade design. By July 2018, it had completed over 1,000 manned flights, with its longest distance flown being 8.8 kilometers. It can stay airborne for about 25 minutes, covering a range of 30 to 40 kilometers, 16 to 22 nautical miles. The aircraft is designed for autonomous flights, which are monitored remotely from a command and control center operated either by Ehang or its customers. Ehang has partnered with Austrian aerostructures supplier FACC AG to certify and produce the aircraft in Europe, benefiting from the simpler certification requirements for aircraft with a takeoff weight under 600 kilograms. In October 2018, the Civil Aviation Administration of China, CAAC, approved initial passenger operations at select locations to help establish regulations for urban air taxis. Since then, Ehang has started taking pre-orders, especially for island-hopping trips and aerial sightseeing at a coastal resort in China. Additionally, a shuttle service across a 1-kilometer stretch of the river in Guangzhou has been introduced, reducing a 30-minute car drive caused by traffic congestion. Ehang has also partnered with United Therapeutics, a US-based biotechnology company focused on manufacturing organs for transplants, to test the rapid automated delivery of organs from laboratories to hospitals by the end of 2019. In March 2020, the Norwegian Civil Aviation Authority granted Ehang a permit for manned test and certification flights, marking the first such approval in Europe. On May 27, 2020, Ehang received the world's first commercial pilot operation approval from the SAAC to use its Ehang 216 AAVs for air logistics. Additionally, the Ehang 216 was awarded a special flight operations certificate by Transport Canada Civil Aviation for test flights in Quebec. The aircraft's general specifications include no crew, as it is self-piloted, a capacity of 2 passengers with a combined weight of 260 kilograms,
can transport up to 2 passengers with a total payload of 220 kilograms over a distance of roughly 35 kilometers with a top speed of 130 kilometers per hour.
A length of 5.61 meters, and a height of 1.76 meters. In terms of performance, its maximum speed is 160 kilometers per hour, with a cruising speed of 130 kilometers per hour and a range of 16 kilometers. The Ehang 216S version has an expanded range of 32 kilometers, powered by a 17 kilowatt-hour battery, and cruises at a speed of 60 miles per hour. Another version, the Ehang 216F, is specifically designed for firefighting, particularly in high-rise buildings. This model can fly up to 600 meters high and carry 150 liters of fire-extinguishing materials. It also comes equipped with a camera that helps to locate fires independently. Evolution of flying cars. Even before the Wright brothers took flight in 1903, the dream of flying was alive. In 1856, a French aviator named Jean-Marie Lebris created a glider that was inspired by the albatross. In one of his attempts, this early flying machine managed to carry him nearly 300 feet off the ground. In 1901, Gustav Whitehead, a German immigrant in the US, reportedly flew a powered aircraft that could move along roads before taking off for the experiment. However, historians generally agree that Whitehead's aircraft did not achieve sustained self-powered flight. When did the real breakthrough happen? And do we have a perfect flying car today? The excitement is building, and it's about to get even more interesting. Companies like Joby Aviation and Archer Aviation are already working on electric vertical takeoff and landing vehicles, eVTOLs. Even major players like Uber and the US Air Force are getting involved, with plans to use flying cars for transporting people and cargo. While the concept of flying cars seems like something out of a Hollywood movie or a Silicon Valley innovation, the idea has actually been around for more than a century. The first patent for a vehicle that could both drive and fly was filed back in 1910. Henry Ford also had high hopes for a single-seat aircraft he called the Ford Flivver, though it never became a reality. In 1917, aircraft designer Glenn Curtiss developed the autoplane, which had a pusher propeller and detachable flight surfaces, including a triplane wing and twin tails. Although it could hop, it never truly flew. In 1935, Konstantinos Vlachos built a prototype of amphibian vehicle with a circular wing, but it caught fire during a demonstration in Washington, D.C. after the engine exploded. Vlachos was severely injured and spent months in the hospital, with the incident being notably captured on a newsreel. The first real success came in 1937, with the Waterman Aerobile taking flight. However, despite its innovative tailless design and 2-seater capacity, it didn't gain much popularity, and only 5 units were ever made. In 1942, the British Army developed the Hafner Rotobuggy, an experimental rotable autogyro designed to airdrop off-road vehicles. The Rotobuggy, in its advanced form, managed to achieve a flight speed of 70 miles per hour. However, with the introduction of gliders that could transport vehicles, such as the Waco Hadrian and Airspeed Horsa, the project was eventually cancelled. Then, in 1946, the Fulton FA-2 Amphibian, a rotable aircraft, was introduced. Though not very practical, It featured removable tail sections and wings, adding to the growing list of flying car concepts. During the same period, the Convair car of the 1940s emerged, which was essentially a sedan attached to an airplane. In 1959, the Canadian and British military created the Avro car, the first flying car specifically designed for military use. It had a saucer-like appearance rather than a traditional car design. Fast forward to 2009, the U.S. Defense Advanced Research Projects Agency, DARPA, launched the Transformer program with a budget of $65 million, aimed at developing a four-person roadable aircraft by 2015. This vehicle was intended to have vertical takeoff and landing capability and a range of 280 miles. Contracts were awarded to AAI Corporation and Lockheed Martin, but the program was canceled in 2013. Around the same time, the Parajet Skycar was developed, using a paramotor for propulsion and a parafoil for lift. The vehicle's body resembled a modified dune buggy. It could reach a top flight speed of 80 miles per hour, with a maximum range of 180 miles in the air. On the ground, it had a top speed of 112 miles per hour and could travel up to 249 miles. In January 2009, Parajet flew and drove its prototype from London to Timbuktu. The Maverick Flying Dune Buggy, designed by the Indigenous Peoples Technology and Education Center of Florida, was created as an off-road vehicle. It could deploy an advanced parachute and travel by air when roads became inaccessible. Weighing around 1,100 pounds, the Maverick was powered by a 128-horsepower engine, which also drove a 5-bladed pusher propeller. Originally conceived to assist remote communities in the Amazon rainforest, it has also been marketed for tasks such as visual pipeline inspection in hard-to-reach areas. The plane-driven PD-1 roadable Glastar is a modified version of the Glastar Sportsman GS2, designed to be a practical roadable aircraft. What makes this design unique is that it largely uses the original aircraft with a modified landing gear pod that houses the engine for road use. Its wings fold along the sides, and the landing gear and engine pod slide backward when in driving mode to maintain balance and improve stability for road travel. The Super Sky Cycle, another roadable aircraft, was an American home-built gyroplane created by the Butterfly Aircraft Company. Interestingly, it was officially registered as a motorcycle. Then, in 2014, Aeromobile introduced version 3.0 of their flying car at a festival in Vienna, Austria. This concept was developed to transform from a regular car into an aircraft. Aeromobile's version 2.5 took 2 decades to develop and made its first flight in 2013. The company's CEO revealed plans to bring flying cars to the market by 2017. By 2016, Aeromobile was test flying a prototype that had gained Slovak ultralight certification, though the final release date or cost details remain unknown. In 2018, they showcased a new design that resembled a sporty flying car with vertical takeoff and landing capabilities. The Aeromobile 2.5 comes with folding wings and a Rotax 912 engine. It can reach speeds of 200 kilometers per hour with a range of 690 kilometers, having its first successful flight in 2013. On October 29, 2014, the Aeromobile 3.0 model was publicly unveiled at an event in Vienna by the Slovak startup Aeromobile. The Aerocar, created by aeronautical engineer Moulton Taylor, stood out from designs like the UFO-shaped Avrocar. It was built to smoothly transition from driving to flying and back to driving without interruptions. Even Ford once considered bringing this vehicle to market. One of the boldest attempts to make flying cars a reality came from Paul Moeller, who invested millions and nearly 4 decades developing the Sky Car. In 2017, he put his creation up for sale on eBay with a set price of $5 million. Today, the future of flying cars looks much brighter. Gone are the days of attaching a plane to a minivan. Vehicles like the Aeromobile 4.0 and Klein Vision Aircar show much more promise for the sky roads of tomorrow. For flying cars to succeed, they need to be safe and reliable on both roads and in the air. Currently, they still require manual operation by both a driver and a pilot. For widespread use, they will also need to be environmentally friendly, capable of flying without requiring a licensed pilot, and priced reasonably for buyers to afford both the vehicle and its maintenance. There are many design variations, ranging from cars adapted to fly, like the AVE Mizar, to planes adjusted for road use, like the plane-driven PD-1. Most of these are purpose-built flying car models. On the road, wheels handle propulsion, while in the air, lift is provided by fixed wings, helicopter rotors, or direct engine thrust. A unique example is the Aleph Model A, where the car's body is hollow and its sides serve as wings. Once airborne, the car rotates sideways, transforming into a biplane, while the cabin remains upright. What do you think of this new flying car? Do you look forward to riding in one? Drop your thoughts in the comments. If you enjoyed this video, remember to like, share, and subscribe to our channel. Don't forget to check out the next video on your screen. You will enjoy it.